All right, go and have your desk spaces cleared except for your speed drill booklets and a pencil. We'll get to a pen in just a little bit when we grade them. Of course, if you want to have one of those at the ready, that's great. We check to make sure we have compasses and protractors. We will start using them in our next lesson. Okay, I wanted to check and make sure we had them today. We will not use them until our next lesson. So those who did not have them have been warned they must have them for next lesson or there will be consequences. For now, though, open up to speed drill number 20. Speed drill number 20. And our last speed drill was just memorization. Do you have these facts memorized? This speed drill gives you twice as much time, a lot fewer problems, but you're going to have to do a little bit of work. You're going to have to do some converting. We're going to have to remember, class, that we go from smaller to larger, divide, and larger to smaller, multiply. And after all, if we're working with the metrics, we just need to remember that King Henry died unexpectedly drinking chocolate milk. If you want to write those letters across the top or bottom of the speed drill, that would be wonderful. You don't necessarily have to right now, but be a good use of your time. You're going to have 3 minutes for this speed drill, and you may begin. Stop. Pencils down. Pens out, and exchange with the person behind you, person in the back. Bring yours to the front. Pencils off your desks. Pens out. Exchange with the person behind you, person in the back. Bring yours to the front. Sign your name as grader. Next to where it says Speed Test 21, there at the bottom of Speed Drill 20. Sign your name as the grader in pen. And these are 8 points each. 8 points each. Going across the top row, 5 pounds equals 80 ounces. 6 cups equals 3 pints. 24 yards equals 72 feet. And 24 feet equals 8 yards. The answers for the top row again are 80, 3, 72, 8. Next row. 102 teaspoons is 34 tablespoons. 7 weeks is 49 days. 7.3 meters is 730 centimeters. And 0.5 kilometers is 500 meters. Again, those answers, 34, 49, 730, 500. Bottom row. 6.5 feet equals 78 inches. 6 quarts is 3/4 of a peck. 280 centimeters is 2.8 meters. And 88 ounces is 5.5 pounds, or 5.5 pounds. Again, your answers for the bottom row, 78, 3/4, or 0.75, 2.8, and 5.5, or 5.5. Figure the total number wrong, multiply that by 8. Get that out of your mouth. Total number wrong, multiply that by 8, and subtract from 100. Question. 8 points each. Yes.
What was 9 again?
Number 9 was 78. 78. All right. Once you got the score on there, also, if you would put it on the score page next to where it says Speed Drill 20, and return to the owner. People in the front, take them to the back. Pass them forward. If you're in the front, take them to the back. And we've been doing a lot with measures, but we've never had to do it where time was a crunch factor, right? Where time was of the essence. So I'm curious, with the pressure to do things quickly, how did we do? Were there any hundreds today? Any hundreds today? How about 92s? You only missed one thing. A couple of you. How about 84s? Just missed a couple. 76, pretty respectable, just missed 3 of them. All right, several of you there, good. Any questions at all? Are there any we need to see worked out? Jalen?
Number 12.
Number 12, we're going from ounces to pounds, so we need to divide by 16 because we're going from smaller to larger. We need to divide by the 16. You may try a guess. You may be not sure because we don't know our 16 times tables. 2 is kind of a lousy estimator. It would go 4 times, but 1's a worse estimator. That would go 8 times. You pick something in the middle. Maybe you try a 6. And, oh, that's too big. Okay, so you go with 5. And, 80, that leaves 8 left over. That's 5 and 8/16 becomes 5.5. Michael?
Just to make sure, so 2 pints don't equal a cup, but 2 cups equals 1 pint.
2 cups equals 1 pint. Yeah, the pint is the bigger one.
Yeah.
So if you're going from cups to pints, smaller or larger, divide. If you're going from pints to cups, multiply. Good. Any other questions? Yes, ma'am.
10.
Number 10. So the first thing we've got to remember is how many quarts are in a peck? 4. Oh, no, that's 8 quarts. That's probably the issue. Right, so we need to divide by 8. We get 6/8, but we don't leave it that way. We reduce it to 3/4. Yeah, so the key thing there was remembering 8 quarts equals 1 peck. All right, yes, ma'am, one more.
5.
Number 5, 102 teaspoons to tablespoons. Remember, the teaspoon's the smaller one, the tablespoon's the bigger one. So we're going from smaller to larger. Divide by 3. 3 goes into 10 thrice with 1 left. 3 goes into 12 4 times, and there's our answer.
Oh.
All right, go and pass those forward if you would, please, now. Pass those forward. And have your textbooks out. You can have them open, if you would, to page 153. Have them open to page 153. And we're going to continue our discussion of plane geometric figures, or geometric plane figures, if you prefer. We've talked about a lot of different figures. We've talked about points and line segments and rays, polygons, closed figures, all different kinds of polygons. Polygons with names that are hard to spell. But fortunately not too hard to remember most of them. Just remembering to spell how to spell them, always a challenge. We're going to talk about angles a little bit, right? Because we've seen that term before, right? We said it's 2 rays or 2 line segments, right, that have a common point, a common end point. What do we call this common end point to our angle? Class?
Vertex.
The vertex. So the vertex, remember, of the angle is the common endpoint. And then the rays or line segments. Again, it could go off to infinity or they could end at predefined points. That's fine as well. If I name these points, I don't know, Q, R, S, for instance. We said there's three names we could give the angle. What's one of the names we could give the angle, Elaine?
Like ARS?
Well, how about angle QRS? And we would, by the way, want to make sure we use the angle symbol to indicate that we're talking about an angle. What's another name we could give the angle, Corey?
Angle R.
There we go, and I like the lazy answer there, right? That's my personal favorite. And then Griffin, the last one.
Angle S, all Q.
There we go. As long as the vertex is either the only letter or the middle letter. Is there a time where I couldn't just use the vertex? This time you can't call it just angle R? What would that other time be, Jalen?
They're like intersecting lines.
Or just another angle at the vertex. For instance, if we had this point at T. Well, if I say angle R, class, how many angles are at R?
2.
Technically 3. I've got this angle, I've got this angle, and I've got this whole thing, right? So technically there'd be 3 angles. I could mean angle TRS, angle QRS, or angle TRQ, right? So we wouldn't want to just say angle R if there's multiple angles at a vertex. I did tell you could do something and cheat the system. Instead of taking the time to use the 3-letter system, if there's multiple angles, I said we could just put numbers. Angle 1, angle 2. And then if you say angle R, we must be referring to the whole thing. And we can kind of cheat that way and be lazy. I'm all about being lazy. What do we call the lines, segments, or rays that make up the angle? The point is the vertex. What do we call the lines themselves? Ben?
Line segment.
Well, they are in this case, but as relates to being part of the angle, Kirsten.
Sides.
They're the sides of the angle, right? So we have sides to our various angles here. Different types of angles we want to talk about as you look at page 153. First angle I want you to note is one that we've already looked at before, and it's not necessarily the first angle, excuse me, not 153. Let's try 151. First angle I want you to note is the right angle. The right angle. And we observed in our classroom lots of right angles. They're everywhere because that's the right way to build things. How many degrees are in a right angle, class?
90.
90 degrees. And to show that something's a right angle, for instance, if I draw this, is that a right angle?
No.
It's close. How do we show that we mean for it to be? Even if it may not be perfect, we're trying to draw a right angle. How would I show that, Ben?
You put a little square in it.
There you go. You put a little square in the corner of it, and that shows, hey, I may not be a perfect artist here, but that's supposed to be a right angle, okay, people? And that's how we show a right angle. Nice perpendicular sides formed. There's another kind of angle, though, that we haven't talked about yet that I need you to know, and it's called a straight angle. A straight angle. Now, we understand that here's our vertex, right? And as we have our vertex, this side, if you will, rotates or opens up just enough to make a nice 90-degree right angle. But what if we have our vertex here, and there's one of the sides, and the other side rotates so much that it actually opens up flat, like a book that's perfectly opened somehow. Or rather, it just makes one straight line. That'd be a straight angle. Well, you realize, class, if we did a 90-degree angle and another 90-degree angle, that would make a straight angle. So if there's 90 degrees in a right angle, class, how many degrees then must be in a straight angle? 180 degrees. Make sure you know that. We've already discussed 90 degrees in a right angle. Make sure you note, there, mark in your books, we're on 151, I think is where we settled on, that there's 180 degrees in a straight angle. These two angles predefine specific number of degrees in them based on how they're defined. But you understand there's not only right angles and straight angles out there, right? There's all kinds of other angles, right? This rotation, I could have opened up just a little bit, right? I mean, that's kind of what I did here. I only opened up a little bit. And this one's really little, right? Really small. An angle that is smaller than a right angle, you know their class is called an acute angle. I always think of it this way. When a little baby is there, everyone always looks at the baby and is like, oh, they're so cute. So little Sam, when he was, 2 weeks old, everyone went to his mom, oh, your baby's so cute. I haven't heard any of you tell Sam that he's cute. He got it a lot when he was 2 weeks old. He doesn't want you to, by the way. But why? Because he's not little anymore, right? But when they're little, they're so cute, right? Y'all with me? Little baby, cute baby. Now, every now and then, there's a baby who's not so cute. But then you just say, oh, how precious. And that's code for, your baby's ugly, mama, but I'm still happy for you. Okay, anyway. Anyway. And then all of you are like, I used to get precious a lot. Is that what they were saying about me? I'm sorry, people. You gotta know.
Yeah, I'm ugly.
Anyway, but acute. No, sir. No, sir. An acute angle. I think of it this way. When something's really little, it's cute. Acute angle, little angle. Know this. Acute angle's less than a right angle. Less than a right angle is acute. What about something that's bigger than a right angle? Well, sometimes we get people, and I don't know if you've ever been accused of this, but they're just not thinking too good, and they just you just can't get anything for them to understand. And it's like, I don't know why you're so obtuse. Somehow that baby that was so cute and little, and then they get bigger, and parents are now pulling their hair out like, why can't you just understand? They're so Okay, so when you get bigger, you get obtuse. Not necessarily have to be the case, it just it feels that way sometimes. All right, so obtuse refers to anything bigger than a right angle, but, class, smaller than the straight angle. It's in between these two. So note the obtuse angle. It's bigger than the right angle, but it's still smaller than the straight angle. You say, Mr. Dasky, could you have an angle bigger than a straight angle? Sure. Right? Just allow that rotation to go just a little bit further. So instead of coming around here and stopping, it just goes a little bit further. And this angle here is bigger than a straight angle. Well, what I like to picture for this one is, how many of you have ever been to the doctor or get a routine checkup? You're not even sick, they're just making sure you're okay, right? And so you sit on the little doctor table thing that supposedly is a bed, but they never let you lay down on it. And you're sitting there, and one of the things they do is they test your reflexes, right? They take a little rubber hammer, and they hit you on the knee, and you kick the doctor in the face. How many know what I'm talking about? Okay. So anyway, this is what I picture. This is like the thigh, and this is like the leg. You're just sitting there on the doctor table, and you're about to get hit up with the hammer to test your reflexes. We call this a reflex angle. A reflex angle is an angle that is bigger than a straight angle. Now, I think all of you have seen acute and obtuse before. I think this may be a new term for you. How many have learned reflex angle before? No. Okay, many of you have. Okay, some of you haven't. So, but most of you have learned the other terms before. So, class, 90 degrees is a right angle. 180 is a straight angle. What's between right and straight? Obtuse. What's smaller than right? Acute. And what's bigger than straight? Reflex angle. Questions on those different types of angles? Yes, ma'am.
Isn't there like one bigger than a reflex?
You could actually go all the way around. You don't have to know this year, but if you were to go all the way around and end where you started, a perfect 360-degree angle is called a paragon. You don't have to know that term this year. But yes, there is an angle that could be a paragon. All right, page 155 now in your textbooks. I want you to do numbers 1 through 9. 1 through 9. Page 155, do numbers 1 through 9.
little purple stuff in it.
Is it wet?
No, I can't touch it. It's right there.
Well, it's probably old. There's a reason we don't allow gum chewing is because, you know,
Correct.
20, 30, 40 years ago, people were irresponsible and they stuck gum under the desk, and ever since then we've had to have a rule that you can't chew gum in school. Maybe it's those people to ruin it for all of us now, huh? Yeah. If only they could have disposed of their gum properly, we never would have had to have such a rule. Well, actually, then there's the chomping sounds that are annoying to everybody, so yeah, I guess that's another reason maybe why we don't allow gum chewing. Several people finish. Take just about 30 seconds longer to be finishing up. All right, numbers 1 through 5, they gave you a chart, and you were either supposed to list the angle they were describing or describe the angle. Number 1, they gave you a description of the angle. They said it's 90 degrees, so what type of angle would that be, Kirsten?
Right angle.
A right angle. Number 2, they said at an acute angle, you needed to tell what was true about an acute angle. Michael?
Acute angle is lower than 90 degrees.
Less than 90 degrees or smaller than 90 degrees. Number 3, an angle that contains more than 90 degrees but less than 180 degrees. Bryson?
Okay,
Number 3.
obtuse.
Obtuse angle, good. Number 4, they said this angle has 180 degrees exactly. Jalen?
Straight angle.
Straight angle. And number 5, a reflex angle. How would we describe that, Sam?
It's above 180 but below 360.
Good. It's bigger than 180, technically less than 360, right? So bigger than 180, technically still less than 360 degrees. Number 6, they just wanted you to name the angle. Give me all 3 names for angle, the one in number 6. Elaine?
Angle XYZ, angle ZYX, or angle Y.
Very good. Number 7, the 3 names for that angle, Corey.
Angle JKL, angle LKJ, angle K.
Very good. Number 8, Griffin.
Angle RST, angle TSR, and angle S.
Excellent. Number 9, Ben.
Angle FED, angle DEF, and angle E.
Excellent job. Everybody got all 1 through 9 correct. You're good to go on this basic understanding of angles. Are there any questions on 1 through 9? Anything about basic stuff about angles, how we classify them that you're a little bit confused on? All right, then let's talk next about pairs of angles. And I think in your textbook, this is on page 152. Let's talk about pairs of angles now. And the first pair of angles I want to talk to you about is something that I actually had up here a moment ago. Remember, I'd drawn this angle, which we called QRS, and then I drew another angle off the same vertex. And we said we could call these 1 and 2. These 2 angles are next to each other. And there's a term that means things that are next to each other. It's the term adjacent. How many have heard that term before? Adjacent. Not necessarily to refer to angles, but just to refer to things in general. For instance, Bryson, whose locker is next to yours? Sam's lockers. So you 2 have adjacent lockers because they're next to each other. In fact, don't actually do this because it'd be slightly strange, but if you were to knock on the wall of your locker, you'd be knocking on the wall of his. You'd just be on the other side, right? Any of you ever done that to annoy your siblings? You knock on the wall. My kids, I tell you. Anyway, but you knock on the wall. If you have adjacent rooms to your siblings. My room was adjacent to my sister's room growing up. And then we moved to a new house and there was a bathroom between us, which was great, except if they got up in the middle of the night and flushed the toilet. Because now the toilet was adjacent to my wall. And anyway, but adjacent just means next to. Well, these 2 angles are next to each other, so we call them adjacent angles, but there are a couple things we need to note. For these 2 angles to actually be next to each other, they first of all, class, have to have the same vertex. Note that. They have to have the same vertex. For instance, if I had these 2 angles, these 2 angles aren't actually quite next to each other because they have 2 different vertices. Does that make sense? Or I draw this angle and then I draw this angle. Well, these angles are close to each other, but they're not actually adjacent because they don't have the same vertex. Does that make sense? That's rule number one. Next requirement for angles to be considered adjacent is they have to share a side between them. And this is actually two requirements. They have to share a side between them. Notice that these two angles have this side that they both use, and it runs right between them. Now, these two do have a common side between them, don't they? But they don't have the same vertex. So we meet one of those requirements. These two angles, they don't share a side, they don't have a common vertex, they're just a big nothing. What about if I have this angle? Let's call it angle ABC. And what about this angle? Let's call it angle DBC. ABC? DBC. Class, do they have a common vertex? Do they share a vertex? Yes. Do they share a side? Yes. Which side do they share, class? BC. Is that side between them, class? No. Then they don't share a common side between them. They're not adjacent. They're actually overlapping angles. Do you see that? The one overlaps the other. Adjacent angles will never overlap because they have, class, say this with me, the same vertex, and they share a side between them. For angles to be adjacent, class, they have the same vertex, and they share a side between them. The next thing that we see here are vertical angles. Now, when two lines intersect each other, notice there are 1, 2, 3, 4 different angles. Look it up this way. Notice that angle 1 and angle 2 share a vertex, and they share a side between them. Class, we would say that angle 1 and angle 2 are adjacent angles. But 1 isn't just adjacent to 2, class. What else is 1 adjacent to?
4.
Angle 4. We would say that 1 and 4 are also adjacent angles. Is 1 adjacent to 3, class?
No.
No. 3 is the only one that is not adjacent. We refer to it then as being the vertical angle of angle 1. Or rather, we can say that 1 and 3 are vertical angles. We could also note that 2 and 4 are also, class, vertical angles. They're across the vertex from each other. Does that make sense? So they're either adjacent when two lines intersect, or they are vertical to each other. Make sense? Now, I want you to note this in your textbook. It says opposite. It means vertical angles are equal. So in your textbook there, and for that matter here, we'd see that 1 and 3 are equal. 2 and 4 are equal. On your book, you have 1 and 2 are equal vertical angles. 3 and 4 are equal vertical angles. Are adjacent angles equal? Could I draw adjacent angles so that they were equal?
Yes.
I could. I could make sure that however much this one rotates, the next one rotates the same amount, and they could be equal. Adjacent angles aren't necessarily equal. Vertical angles are always equal. So an interesting thing to note there. A couple more terms that we notice here. The terms complementary and supplementary. And I believe these are terms you have learned before. Are we familiar with those terms, complementary and supplementary, from past years? Some of us are, some of us aren't. Complementary angles, just note this, two angles that add up to 90 degrees. Two angles that add up to 90 degrees. The word complement has two meanings and two spellings. If I say, Jalen, you look very nice today, that's a compliment, right? But we spell it with the letter I, compliment. Think of it this way, I like compliments. Mr. Nadasky, you're such a wonderful math teacher. Mr. Nadasky, you're so good looking. Mr. Nadasky, you're so smart. Mr. Nadasky, you're just wonderful. Okay, I don't actually ever hear that, but I mean, if I did, I would like that, right? I, the letter I, like compliments. Compliment, notice the spelling in your book. It's not complimentary, they're complementary. Okay? Complementary has the idea of completing something. Head offhand, good posture there, Ben. Complementary has the idea of completing something. What are we completing? Well, if things are supposed to be done right, then completing a right angle is complementary. Does that make sense? Mm-hmm. That's hence the term. So if I have, for instance, this angle, ooh, that ain't right. So we got to make it right. How do we make it right? Like that. Maybe that was a little off. Like that. Now, the whole thing is right. this angle plus the next angle together. They work together to make a complete right angle. Does that make sense? So, two angles that add up to 90, class, we call complementary angles. Again, for Michael's sake. Class, it's Thursday, but it feels like Friday, doesn't it? Two angles that add up to 90 degrees or make a right angle with each other, class, are complementary angles. Supplementary has the idea of making a full straight angle. Okay, supplementary angles, they make a straight angle. So that's how I remember supplementary. They make a straight angle, which means, class, they have to add up to how many degrees? 180 degrees. So you see that there. By the way, come back to these vertical angles for a minute. I told you vertical angles are always going to be equal to each other, right? What about, though, these adjacent angles? Remember we said 1 and 2 are adjacent. They are. What else are they, class? Supplementary. Do you see that together they make a straight angle? So that these two non-vertical angles, the adjacent angles, will be supplementary. The vertical angles will be equal. 2 and 3, class, will be supplementary. 2 and 4 will be equal because they're vertical. 2 and 4 are vertical, so class, they're equal. 3 and 4 are adjacent, so they end up being supplementary. They add up to 180 degrees. Now, one of the things we can do then is look at the example problem, 4.4a. If you're given a particular angle, you could find the complement or the supplement. How? Well, look at the example. They tell us that angle x is how big? Elaine?
75 degrees.
75 degrees. And if we're going to find the complement, head off hand, okay, help yourself stay awake here. If we're going to find the complement, class, we have to find two things that add up to 90. So we know that one of the angles is angle x, that's 75 degrees, plus something else has to equal 90 degrees. Well, class, how would I figure out what that missing angle is? Just subtract 75, and that's where we get 15 degrees. So write this in the side margin of your book. To find the complement, subtract from 90. To find the complement, subtract from 90 degrees. Because they add up to 90, we subtract from the 90. We subtract from the total we want to get. What would we do to find the supplement then, class? Well, class, supplementary angles add up to 180 degrees. So to find the supplement, then we should subtract from 180 degrees. Write that in the side margin. To find the supplement, subtract from 180. To find the supplement, subtract from 180 degrees. And you see that's what they did there. They said 90 minus 75, 15 degrees. That's the complement, bless you, of angle x. They said 180 minus 75, that's 105 degrees. The supplement of angle x must be 105 degrees. Look at the next example. We could also compare a couple angles and see, are they complementary, are they supplementary, or are they just a big nothing? Well, the first pair of angles you see in letter A is R and X. R is 20, X is 70. Class, what do 20 and 70 add up to? 90. Since they add up to 90, they must be complementary. Look at the next two angles, 64 degrees and 105 degrees. Well, what do they add up to, class? 169 degrees. So are they complementary or supplementary? Neither. They'd have to add up to what to be complementary? 90. And have to add up to what to be supplementary? 180. They don't add up to either one of those. They're not complementary or supplementary. Easy enough there? All right, turn the page. Over to 155 again. Turn back to page 155. I want you, on numbers 10 through 13, only to find the complement. Which means, class, what are we doing? Subtracting from 90 degrees. 10 through 13, find the complement. All right, number 10. When you subtract 30 degrees from 90 degrees, you get what complement, Kirsten?
60 degrees.
60 degrees. Number 11. When you subtract 12 degrees from 90 degrees, you get what complement, Ben?
78 degrees.
78 degrees. Good. Wake up. Number 12. When we subtract 61 degrees from 90 degrees, Sam, we get what complement?
29
29 degrees. Good. By the way, degrees, that unit we measure angles in, right? All angles measured in degrees. Number 13. We find the complement of 45 degrees. What do we get, Jalen? 45 degrees. Class, notice complementary angles can be equal, can't they? If they're each half of 90. Do complementary angles have to be equal? No, they usually aren't. But if they're both 45, they could be. Now at your seats, I want you to go through and find the supplement, which means, class, we're subtracting from 180. Now go through same things, but find the supplement of each of those. Same problems, 10 through 13. We found the complement. Now we're going to go through the same problems again, find the supplement. Yes. All right, number 10. We said that the complement was 60, but what's the supplement of 30 degrees, Jalen?
90 degrees.
On number 10, what is the supplement of 30 degrees?
90 degrees.
How do we find the supplement?
Subtract from 180.
So if we take 180 degrees minus the 30 degrees that they gave us, what would the supplement be? 150 degrees. There we go. That's the supplement there on number 10. What about number 11? What's the supplement, Bryson?
168.
168 degrees. Sorry to wake you up. Number 12. What's the supplement, Michael?
119 degrees.
119 degrees. Number 13, Griffin. What's the supplement?
135 degrees.
135 degrees. Questions on finding complements or supplements? Pretty easy. All right. Now, numbers 14 through 19, you're going to determine, are they complementary, supplementary, or neither? Here's what I'm going to let you do since you were lazy. If they're complementary, just write comp. If they're supplementary, just write sup. Not as in sup, man, but S-U-P-P. And then if they're neither, just put a capital N. All right, so we'll be lazy. Complementary, supplementary, or neither. So what should you do with the two angles they give you, class? Add them and see what their sum is. If the sum's 90, they're complementary. If the sum is 180, they're supplementary. If it's not 90 or 180, neither. So number 14, Corey, those two angles are?
Complementary.
Complementary because they add up to
90.
degrees. 90 degrees, good. Number 15, what's the verdict there, Elaine?
Neither.
Neither, because they don't add up to 90 degrees or 180 degrees. They only add up to
160.
160 degrees. Number 16, Sam?
Supplement.
Supplementary, because they add up to
Add to 180.
180 Degrees is correct. Number 17. What's the verdict, Ben?
Neither.
Neither. They add up to 200 degrees, right? That's not anything special. Number 18, Kirsten.
Complementary.
Complementary, because they add up to 90. And number 19, Michael. Supplementary, because they add up to 180 degrees. Good. Look at the next page. They have given you two angles on number 20. They've given you a 165 degree angle. Class, what kind of angle is 165? Obtuse. And they've given you the adjacent angle is 15 degrees. They want you to find the other two angles. Well, class, angle 1 and the 165 degree angle are considered to be what?
Vertical.
Vertical angles. And what do we know about vertical angles, class?
They're equal.
They're equal. So what's angle 1?
165.
165 degrees. Do you see you don't have to do any math?
Yeah.
Don't you love it when you don't have to do any math? What about angle 2? How big is angle 2 going to be, class? 15 degrees, because angle 2 is the vertical angle of the 15 degree angle. Do 21 and 22. This should take like 20 seconds.
Yeah.
Not trying to insult your intelligence or anything here, but you know. Testing your reflexes. Number 21. What is angle 1, Bryson?
1.4.
Uh-oh. What angle is 1 vertical to? Hey, Bryson. Vertical means across the vertex. Right across from each other. Those are the ones that are going to be equal to each other. And then these two will be equal to each other as well. Does that make sense? So for angle 1, 1 is vertical to the...
I don't know why.
Okay, look directly across from angle 1. You see angle 1 right there, the number 1? Look directly across. What is it? That's what we mean by vertical angle. Okay, and then directly below angle 2, across the vertex from angle 2 is 124. Does that make sense now? All right. So on number 22 then, Bryson, what is angle 1? 148 degrees. There we go. And angle 2 is going to be 32 degrees. Class, what do we notice about the two red angles they marked on each of those? They are adjacent, but they're also supplementary. So on number 23, they only gave you one of the angles, class. They only gave you the 86 degree angle. Well, which other angle, without doing any math, do we already know, Jalen?
86. Right.
Which other angle, besides the 86 they gave you?
2.
Angle 2. It has to be how big, Jalen?
86.
86 degrees. Everybody get angle 2, 86 degrees, no big deal, they're vertical angles. But to figure out either 1 or 3, class, we're going to have to find the... Not complement, supplement, because together they're going to add up to 180. So what is the supplement then of 86 degrees, anyone?
94.
94 degrees. That must be how big angle 1 and angle 3 are. Does that make sense? Any questions on that? Do 24 and 25. Find the 3 missing angles now. All right, number 24, they gave us a 107 degree angle. Which other angle should we be able to find without any work at all? Ben?
2.
Angle 2 has to be
107.
107 degrees. How many at angle 2 is 107 degrees? How do I find either angle 1 or angle 3, Sam? Good, because I know that together, these two, 1 and 107, add up to 180 degrees, so I just subtract to get how big for angle 1? 8. And if that's angle 1 class, that has to also be angle 3, which is the vertical angle. How many in all three of these answers correct? 73 degrees, 107 degrees, 73 degrees. For number 25, what did you get for angle 1, the supplement, Corey?
41.60.
For angle 1?
Oh, for angle 1.
Yeah.
49 degrees.
Say that again?
49 degrees.
Oh, Corey, look. Do these two angles add up to a right angle? They add up to what?
180.
A straight angle. They add up to 180. We've got to subtract from 180 then. So what should we have for angle 1? Anyone?
139.
139 degrees is what we should have had for angle 1. What about angle 2? How big is angle 2, Corey?
41.
That's 41 degrees. And now, Corey, how big should angle 3 be?
139.
139 degrees. Hey, anybody got an idea of how we might check this? Michael?
Could we possibly add 41 and 139 degrees to see if it makes 180?
Kind of, you could. What would we get, class, if we went all the way around?
360.
You could, if you wanted to, and I don't usually do this because I'm lazy, right? But you could add all 4 angles and make sure they all add up to 360. That could be a way you could check. Homework for this weekend. Don't forget your compass and protractor. You must have them next lesson. Page 158, do numbers 1 to 24. Page 158, do numbers 1 through 24. So take a look at that homework, and we'll begin using compass and protractor, well, protractor particularly, but compass and protractor in our next lesson. Have a wonderful rest of your day, and when the bell rings, you are dismissed.